about air compressors from you.
Yeah, ma'am, thank you.
Okay, everyone, now you are live across the globe. Bye.
Thank you. Thank you,
Thank you,
sir.
sir.
Yeah, thank you. Should I start now?
Excuse me, sir. I introduce to you.
Okay, okay.
Hello. Good morning, everyone. Myself, Mehul Padiyar. Behalf of Parallel University, I heartily invite to you Mr. Rakesh Bhumtaria, sir. He is a assistant professor in a Porbandar Government Engineering College. Uh, he completed his BE Engineering from Birla Vishwakarma Mahavidyalaya, Vidyanagar. He completed his master MTech from MS University in thermal engineering, and he pursuing his PhD from Gujarat Technological University. His topic is about in a Sterling engineering. Uh, his job profile is he's a working as a lecturer in a Paro University. After that, he's a working on Marwadi University, and his research and development area is so very good. Now he is pursuing his PhD from GTU, and he is a vast experience regarding the research, and he is now currently working on Stream Sterling engine. Okay, so today our topic of our webinar is a basic air compressor and its industrial application. And I hope all of you are all participants, all faculty members, and all my invitees are uh, this webinar in a interactive mode for questioning answering. So finally, I give this session to Mr. Rakesh Bhumtaria sir. Thank you, Rakesh Bhumtaria sir, and heartily welcome from behalf of Paro University and entire our mechanical department of diploma engineering. Thank you, sir.
Okay, thank you, Budya. It's a very inspirable for me that my seniors are introducing me. Rajasthan Madam, Bindi Madam, and Patia all are my seniors when I was working with Pablo. Uh, Without wasting my time, let's we start our session. Today, I am just going to present a webinar on basics of air compressor and industry application. By keeping in the mind, I have prepared this presentation based on level of diploma student and little bit higher than diploma level. So I hope that you will enjoy this session. The outline of this session contained with definitions, application of compressors, classifications, reciprocating air compressor, its construction, working, few things related to clearance volume in reciprocating compressor, then need of multi-staging, and finally I will discuss few things related to two-stage reciprocating air compressor. Uh, Before starting any topic, there is one curiosity in mind regarding the basic of that topic. So in this topic, we have curiosity what is compressor. Because we are discussing related to compressor. And basically, we are here discussing related to air compressor. So we'll basically discuss with air compressor. What is compressor? Look, we have few things related to compressor. If anyone tells that what is compressor, then we simply say that it's some device like we produce pressurized air. Or we can simply say that we supply pressurized air. Yeah, right. The compressor is something related to that we produce or supply pressurized air. We can say pressure potential energy in the form of pressure energy. Yeah, right. Uh, uh, we agree to one. Simply we can say that it's something device something like that produce pressure energy or potential energy of air is known as air compressor. Yeah, right. But let me go in little bit depth that we all are aware with first law of thermodynamics. What it says? It says that energy neither created nor destroyed. It will just simply transfer from one to another one. Then there is some confusion here. If compressor produce pressure energy, then what happens with first law of thermodynamics? Then definitely we have some input there. If compressor produce pressure energy, then there might be some input to produce that pressure energy so that first of all didn't get violated. So here we must have some form of energy to give supply energy in the form of any other form of energy. So what will be that energy as an input to produce pressurized air? And definitely the answer is mechanical energy. So we can say that now we can deeply say that compressor is device in which we supply mechanical energy from one end and it will deliver pressure energy from another end. So that now the first of component is fully applicable with this device. Now, another thing, here we are dealing with mechanical energy. So we definitely say that compressor is one type of mechanical device. So we are considering compressor in our mechanical device portion. We are considering our mechanical device portion. So now picture is clear that compressor is mechanical device. Another thing, let's go with some little bit more detail. If compressor is mechanical device, then there are two chances for mechanical device. Which are the chances? One is our producing device, other one is power consuming device. Because mechanical devices are basically two types of device. One is power producing, another one is power consuming. What is power producing device? Our producing device means a device which produce mechanical energy. Means from that device we get out as a mechanical energy. What is power consuming device? Then simply say that a device which runs on mechanical energy, or a device which needed mechanical energy to then run or functionalize. That is function. So here we are supplying mechanical energy, means our compressor is power consuming device, not power producing device. So compressor, pump, blowers, it's all devices which consume mechanical energy and produce any another form of energy. So it's called a power consuming devices. Whereas IC engine, turbine, etc. are devices which produce mechanical energy output. So we need supply any another major source of energy. So these all devices like turbine and internal combustion engine are power producing devices. Now we can say that let's say we put all words in one single common line. So we can say that a compressor is device, not mechanical device, but a mechanical power consuming device which converts mechanical energy into potential energy is known as compressor. The definition of compressor is clear now with depth and knowledge that power consuming mechanical device which converts mechanical energy into pressure energy or potential energy of air is known as compressor. So simply we can say that compressor is one type of box. In that box we are giving mechanical energy in the form of sharp power on one end, and we are getting pressure energy in the form of compressed air at another end. And the question in mind is that how can we generate or how can we get mechanical energy to run the compressor? Then there are basically three most popular major sources of energy available to run the compressor. The first most popular and the source of energy to run the compressor is electric motor. This was widely used when electrification is possible and electricity easily available. Then we simply use electric motor to run the compressor. But places where electricity is not easily available, electrification is not possible, right? Like the remote places, then you cannot electric motor. Then another one option is internal combustion engine. Using internal combustion engine, we can run the compressor. And third, most important source of power is turbine. This option is majorly used only and only in gas turbine power plant, where turbine side shaft is directly coupled with gas turbine, so that gas turbine will supply mechanical energy through the compressor. So there are basically three sources of power: electric motor, IC engine, and turbine to run the compressor. Clear? Good. Thank you. Now let's discuss application of compressor. There are a wider range of application uh, where we use pressurized air for functionalization, and whenever we need pressurized air, there is a need of air compressor. So there are so many applications in industry as well as domestic where we are using air compressor. Let's discuss few of them. First one is refrigeration system. Well, we are aware with refrigeration system in which we need to compress refrigerant and circulate within a cycle. So in refrigeration system, there is a use of compressor. Then pneumatic tools like drill, hammer, riveting machines, which are basically most popular in the automation industry. They are run with pressurized air, and so we need compressor in place. Air motors in mind. Uh, this is most popular and most important application of air compressor because what happened in mine, like coal mines, if we use uh, IC engine to run the instrument for mining work, then there are chances of high hazards due to combustion of conventional fluid like petrol, diesel. So we cannot use IC engine at that place. And another chance is we can use electric motor, but due to electric sparking, there is also chances to get high hazard. So in mostly coal mine, air motor is used to run get the devices, and for running the air motor we need compressor. In gas turbine power plant, using compressor, we are supplying pressurized air to combustion chamber for total combustion. Then air cooling automotive, this is most popular application. We all are aware with this application. Then spray painting purpose. Then supercharging AC engine, we are all aware with the, that thing that if we need to improve the performance of our engine, it is necessary to get supercharged. Probably sandblasting, which is related to surface hardening of material. So in sandblasting, there is need of pressurized air, and we are using compressor, operating blast furnace, and operating air brakes in burst curve and penetrant. Next, we discuss classification of compressor. This is most important and most concentrated part of my presentation. How can we classify the compressor? There is, uh, there is two types of compressor. One is positive displacement type compressor, and another one is rotodynamic type compressor. Let's discuss a little bit more in this point. What is positive displacement type and what is rotodynamic? Basically, any mechanical device, not any mechanical device, but any engineering device. When engineer is going to design, then they design that device based on simple law and principle of nature. So our target here is to compress the air, is to increase the pressure of air. Then how can we develop such a device which give us pressurized air? And using which law we can develop such type of device? And technograph, engineers, scientists, researchers like you and me are planning and designing such a device which produce pressurized air. So they are searching with different laws which are easily available. So from that laws, they use P inversely proportional to B. We are all aware with Boyle's scale, and Child's law. So we all are aware with that law that pressure is inversely proportional to volume. Means there is relation between pressure and volume. If we change volume, then there is definitely change in pressure. So here our target is to get pressurized air. By that principle, if we somewhat how, if we decrease the volume of system, we will get less of air. So here our target to reduce the volume of air, and by reducing volume of air, we are getting less of air. Based on this principle, if we design any compressor, then such type of compressor is known as positive displacement type compressor. What is positive displacement? Let's I repeat again. A compressor in which pressure is produced due to change in volume, then such types of compressor is known as positive displacement type compressor. So based on that principle, so many engineers have designed positive displacement type compressor. Then another one is software development. Then few other researchers, scientists, engineers are searching to design and develop compressor based on another principle, working principle, and they found that there is Euler's principle, Euler's formula that P upon 2G plus V square upon 2G plus Z is equal to constant. Let's we ignore Z means potential energy, means height. Then there are two components, P upon 2G plus P means pressure, V square upon 2G means V for velocity is equal to constant. So we can say that pressure is directly proportional to velocity. It means if we change velocity, then there will be definitely change in pressure. If we increase velocity, then definitely pressure will increase. If we decrease velocity, then pressure will definitely decrease. So based on that principle, design compressor are known as thermodynamic type compressor. So let I repeat again. What is a thermodynamic compressor? Thermodynamic compressors are compressor which are designed based on principle that pressure change due to change in velocity. If we are changing velocity and getting pressure, then it's known as thermodynamic. If we are changing volume and we are getting pressure, then it's known as positive type. Next we go a little bit with positive displacement type compressor. So now picture is clear that in positive displacement type compressor there will be change in volume. And if we need to change the volume of air, then there must be one moving element. And based on due to that moment of that moving element, the volume might be changed. So how can move that moving element? So, is there any problem? So,
No, sir.
okay. I am getting some little bit noise from another side. So, okay, let's continue. Uh, what happened? We need to change it. We need to. Will it possible to stop this noise? But yeah, sir. Will it possible to stop this noise? So we are in.
All the participants, please turn off your
Yeah, thank you. Okay. So we need to change volume, and for changing purpose of that volume, we need to move any element, any element, any body. So let's we think on that. How can we move one body? What will be the motion of that body? And there are two chances. Number one, we can move that body in vertical position, in horizontal position, or inclined position. That's known as straight line motion. In mechanical terminology, that's known as linear motion. So we can move any body in linear motion, like vertical, horizontal, or inclined. This is known as linear motion. Another chance is that we can move any body in angular motion, which body will change angle continuously. And such type of body is known as angular. Then motion is known as angular motion. So if body move in linear direction, if body move in linear direction, and due to movement of that body, volume change and pressure increase, then such type of devices are known as reciprocating. Uh, uh, volume change due to change in linear motion of body, and due to change in volume, there is change in pressure. The example of reciprocating compressor are single stage reciprocating compressor, multi-stage reciprocating compressors. Let's discuss with angular motion. If body moving in angular motion, then such types of compressors are known as rotary compressor, in which body will move in angular direction, and due to change, movement of angular direction, the volume will change. Due to change in volume, pressure will change.
Excuse me, sir.
Yes,
One of the students have sharing their presentation, so I have to inform that they don't have the present now. Harsh Patel, Harsh Patel, please turn off your present now screen. Do not share your screen. Hers Patil. Hers Patil, please turn off your sharing screen. Okay, sir, you can restart your ear. Doesn't respond me.
Okay. Okay.
Rakesh, sir, you
Yeah.
can restart your present, share your present screen. आपका वो प्रेजेंट स्क्रीन वाला है वो स्टार्ट करो दो वापस
Okay. Okay.
ये हर्ष पाटिल ने किया है
Okay. Will my presentation be visible to all?
No, sir, your presentation is not visible.
Okay. Let's try.
As the one of the students have now,
Yeah.
Hers Patil have turned
Now
off his
visible.
sharing screen. Now you can,
Okay. Yeah.
Now you can share the screen. Share the screen.
Visible now. Visible now.
Yeah, you the screen. Your presentation is not visible here.
Yeah. Let's try reconnect the presentation.
Yeah, you have to share your presentation again. Start the presentation again.
Okay. Okay. I will do it. Okay, visible now.
Yes, sir. Is it
Okay.
visible?
Thank you, ma'am. Okay, thank you. Let's continue with rotary compressor. What is rotary compressor? Due to angular motion of the body, a change in volume. And due to change in volume, pressure will change. And such type of compressors are known as rotary compressor. Let's take example like vent type compressor, screw type compressors, cold type compressors. Let's read example of rotary type compressor like centrifugal compressor, axial flow compressor, and mixed flow compressor. Apart from this classification, there is one another terminology based on pressure ratio. What is pressure ratio? Pressure ratio means a ratio between the outlet pressure or delivery pressure to suction pressure or inlet pressure is known as pressure ratio. Majority uh, three terminology or three technical words used with the pressure ratio. One is fan, another is blower, and third one is compressor. Majority when pressure is around 1.1, means lower pressure ratio, then the terminology is known as fan. If pressure ratio is middle one, then is known as blower, and if pressure ratio is higher one, then is known as compressor. Do anyone think that why they have given three terms? One is fan, another one is blower, and third one is compressor, based on that pressure ratio. Is it no? Can we give name like low pressure compressor for fan, medium pressure compressor for blower, and high pressure compressor for compressor? Yeah, we can give that name also, but they didn't have used that terminology like low pressure compressor, medium pressure compressor, and high pressure compressor. But they have used terminology like fan, blower, and compressor. Why? Is there something additional apart from that pressure ratio? Yeah, there is something special and there is some additions apart from pressure ratio, and because of that some additions we are knowing that devices like fan, blower, and compressor we are not using word like low pressure compressor, medium pressure compressor, and high pressure. What is that addition? Let's explain. Let's we take first device as fan. What happened in fan? So suppose this is one is fan. We are giving mechanical energy to movement. Then what happens? Due to the mechanical energy, air will suck from one side and it will deliver to another side. So from where air will suck? And definitely the air will suck from atmosphere. When did this air suck from atmosphere? At that time, the pressure of air will be little bit nearby atmosphere, little bit lower the atmosphere. So we can approximately say that in atmospheric pressure. So can consume air from atmosphere at atmospheric pressure approximately. And what happened? By consumption, by adding mechanical energy, it will deliver at another side. So at delivery point, pressure of air will be such a light a little bit higher than atmosphere. So we can roughly say that it atmosphere pressure. So the fan will just simply produce 1.1 pressure ratio, which is negligible near about 1 pressure ratio. So we can call that fan will assume suck air at atmospheric pressure and it will deliver air at atmospheric pressure just by adding only velocity in the air. So fan will just simply increase the velocity of air, but it will not increase much higher pressure, just simply 1.1 pressure ratio. What happened in blower? Let's take example of blower. What happened in blower? Air will suck from one side, air will give it from another side by mechanical energy as the input. So what happened? By supplying mechanical energy, blower is consume air from atmosphere, then the pressure of air will be near about atmosphere. So blower will consume air at then what happened? Blower will supply air at another side. But during this supply, there is difference. That blower always delivered air at more than atmospheric pressure. So what happened? Blower consumed air at atmospheric pressure and delivered at more than atmospheric pressure. And third one is compressor. What happened in compressor? With compressor, we are giving mechanical energy. Compressor will run. It will consume air from atmosphere. But now the compressor will not consume the air at atmospheric pressure, but it will consume the air at lower than atmospheric pressure. So always there will be vacuum at the inlet of compressor. So compressor always consume air at lower atmospheric pressure and it will deliver air at higher than atmospheric pressure. So now I think the doubt in your mind might be clear between fan blower and compressor. What happened? Let's repeat it. In fan, air supply at atmospheric pressure, air delivered at atmospheric pressure. Simply, in compressor, air is supply at atmospheric pressure, it will deliver more than at atmospheric pressure. In compressor, what happened? Air will supply from lower than atmospheric pressure and it delivered to higher than atmospheric pressure. This one is basic difference between fan, blower, and compressors. I think you get your point. Thank you. Let's discuss single stage reciprocating compressor. Firstly, we will discuss construction of single stage reciprocating air compressor. This reciprocating air compressor firstly contained with major three parts known as crankcase, cylinder, and cylinder head. This portion is known as cylinder, which is basically used to follow the piston. This one is crankcase, which is cover cylinder from bottom one position. There are two main functions of crankcase. One is to prevent the internal mechanism from external dust and other particles. And another one is in crankcase there will be always lubricant which used to lubricate the mechanism. So two functions of crankcase. One is prevent from external body. Another one is to provide storage for lubricant. So this one is crankcase. Third one is cylinder head, which is basically used to accommodate the valving mechanism in that portion. Apart from this, third, fourth most parts in single stage reciprocating air compressor is piston, which is basically used to make reciprocating motion within a cylinder. And piston is connected with another most important device that has connecting rod. This one is connecting rod. And this connecting rod is connected with crankshaft, which is basically used to convert reciprocating motion of piston into linear motion, linear motion to reciprocating to linear motion of our mechanism. Then, apart from that, there is one suction valve, a topmost position in cylinder head. Suction valve is basically used to supply the fresh air from atmosphere to cylinder, and there is another delivery valve, which is basically used to deliver air from cylinder to our application or receiver. So these are the main basic parts of single stage reciprocating compressor. Apart from this part, there are few more like cooling water circuit in water cool compressor, for cooling the compressor, for fin in air cooling system, but they are not much important for this presentation, so I didn't for the parts. Let's we discuss few terms related to single stage reciprocating compressor, which are very important to learn the reciprocating compressor. Then let's we put schematic diagram of compressor, and this one is schematic diagram simple one. Then in the schematic diagram, its diameter of cylinder is known as bore. What is bore? Its internal diameter of cylinder is known as bore. Clear? Then second one, most important terminology is TDC, means top dead center. Uh, in general, majority book, the word top dead center is concerned with, they define that what is top dead center. They define that when piston is at top condition, that is known as TDC, top dead center. But I would like to redefine that definition of TDC because it's a little bit confusing. Word. But we can simply say that when piston is at TDC, means ordinary at top dead center or top condition of cylinder, then what happens? The piston will at extreme most distance from crankshaft. So when piston is at extreme most distance from crankshaft, then this uh, portion is known as the center is known as TDC, means top dead center. So this one is top dead center. Another terminology is BDC, means bottom dead center. In general, it says that when piston is at bottommost condition, then is known as BDC, means bottom dead center. But let's we redefine that definition also. We can call it when piston is at BDC, at that condition, piston will be at closest most condition with crankshaft. Means when piston is near about closest one with crankshaft, then not known as PDC. And when it's far away from crankshaft, it's known as PDC. So I think now the concept is clear for PDC and BDC. Then the distance, both most important terminologies. The distance between PDC and BDC is known as stroke. When piston travel from PDC to BDC or piston travel from BDC to TDC is known as stroke. These are the most important terminology. Thank you. Let's we start with working of single stage reciprocating air compressor. For simplicity and understanding of working, we assume that there isn't any clear volume. Ideally, there isn't any clear volume compressor. So we will discuss compressor without clear volume. What happened? Let's we take this schematic diagram here. This one is schematic diagram already we have done from construction point of view. So let's we start working. Before starting working, uh, let's we put PV diagram together so that the internal mechanism also will be most understandable for what happened in PV diagram also. So we will plot this PV diagram along with understanding of working. What happened? Before starting any system, any cycle, commodity cycle, piston should be at TDC, means it should be at top dead center. So initially, piston must be at TDC for the starting of cycle. Initially, our piston is at TDC and cycle will start from TDC. Okay. Let's we supply mechanical energy to run the compressor, and we will supply mechanical energy in the form of shaft power to run the compressor. And due to the supply of that mechanical energy, our this one crankshaft will rotate. And due to the rotation of our crankshaft, connecting rod will move towards bottom. And due to motion of this connecting rod, piston will try to move from TDC to PDC. Due to motion of piston from TDC to BDC, what happened? Make some concentration at this point. What happened? What happened? When piston made from BDC to BDC, due to motion of the piston, I am getting my voice back. Kindly switch off your speaker if anyone using your speaker. Okay, thank you. When piston move from TDC to BDC, and due to motion of piston from TDC to BDC, the volume between piston and cylinder head will get increased. You can logically think that. So, due to moment of piston from TDC to BDC, the volume between cylinder head and piston will get increased. Then we all are aware that volume is inversely proportional to pressure. Volume is inversely proportional to pressure. Then what happened? Due to increase in volume, pressure will decrease. So pressure will get slightly lower than atmosphere. Slightly lower than atmosphere. Then what happened? The pressure inside the cylinder is slightly lower than atmosphere, and the outside pressure is atmosphere. Due to that pressure difference, here suction valve will open and it will open. There isn't any mechanism like IC engine to operate this suction and delivery valve. Here suction and delivery both valves will operate due to only pressure difference. Due to pressure difference, suction valve will open. And due to opening of suction valve, air will come from atmosphere towards cylinder, and cylinder will fill with atmospheric air. So again, our pressure will be at atmosphere level. So during this process, air will come inside the cylinder. This process is known as suction process. Now clear? What is suction process? During that suction process, piston will move from TDC to BDC. Due to movement of piston from TDC to BDC, volume will increase. Due to increasing volume, there will be slighter pressure difference, and due to that slighter pressure difference, suction valve will open and fresh air charge from atmosphere is supplied to our cylinder, and our cylinder will maintain a constant atmospheric pressure. So during this process, volume will increase, but pressure will not increase. It will slightly increase, but again it will maintain at atmosphere. So we can say that it remains constant. Let's we put this process in PV diagram, and we can say that you can visualize this thing. Pressure remains constant, but volume is getting increased. So process 421 is suction process. Now our piston is at BDC, means bottom dead center at this position. Now what happened? Now due to continuous motion of crankshaft, piston will move from BDC to TDC. Piston will move from BDC to TDC. So when piston move from BDC to TDC, then the volume of cylinder will get decreased. And due to decrease in that volume, as per law, pressure is inversely proportional to volume. The pressure will get increased. So during this process, volume will decrease and pressure will increase. But here, discharge valve will not operate because discharge valve is designed in such a it is occupied in spring and designed in such a way that it will operate only and only after getting required pressure. Let's say we have requirement of 6 bar pressure. So if cylinder gets 6 bar pressure, then only this discharge valve will operate. Otherwise, this discharge valve will not operate. So let's assume that we are piston will move from BDC to point X. I have plotted one imaginary point X. So during motion of our piston from BDC to X, cylinder volume will decrease, pressure will increase, and compression will happen. So let's put this process in our view diagram. So this one is our compression process. What happened? Volume will decrease, pressure will increase. So volume is getting increased, pressure is getting increased. So 1 to 2 different process is compression process. let's we assume that this one is isothermal process. But in actually, what is isothermal process? We are that in isothermal process, there should not any change in temperature. But what happened in practice? When compression process take place, when air get compressed, then there is always chances to get rising temperature. So it's much difficult to maintain constant temperature. If we have to maintain constant temperature, then there is a need to make our system very very slow, which is not practically possible. So we cannot use isothermal compression process. So compressor will not follow the isothermal process. Then which process will do? Then another chance is to follow the compression is adiabatic process. What is adiabatic process? There is a heat transfer. This one is adiabatic process. So what happened in adiabatic process? The slope of adiabatic process is little bit away from isothermal process, and we all are aware during our thermodynamic study that area covers under the PV diagram is known as work transfer. If we use adiabatic process, then the work or power consumption to run the compressor will definitely get rise, and which result in more power consumption. So it's much difficult to follow the adiabatic process. So technical like you and me, they have designed the process in between isothermal and adiabatic. This process is known as polytropic process. PV raised to n is equal to process. So compressor always followed by PV raised to n is equal to process, which polytropic process. So compression always happen in compressor using polytropic process only. And whatever up to X level we get what discharge pressure. Say let's we have designed for 6 bar and we get 6 bar pressure. Then what happens? By getting 6 bar pressure, the design spring will operate. The discharge valve will get opened. Piston will move from X to TDC. Piston will move from X to TDC. And due to motion of piston from X to TDC, this discharge valve will get operated. And due to operation of the discharge valve, the air inside the cylinder will get delivered at constant pressure. So there isn't any chances of getting pressure change, but at constant pressure, the air will discharge to our system. This one is third process, delivery process. Let's do this process in our PV diagram. What happened in this process? Piston will move from X to PDC. And due to motion of piston from X to PDC, the volume will get decreased, but pressure remain constant. So the process will be a little bit like this. Three process. So this one is daily process. Here, I think now the picture is clear. Compression, single stage engine compression works with three processes. One is suction process, in which air will get inside the cylinder. Another one is compression process using polytropic process 1 to 2. Third one is delivery process, in which air is delivered from cylinder to or required application cylinder. This one is PV diagram of single stage system. During this working, we assume that there isn't any clearance volume, but in actual practice, there is always little bit clearance in compressor. What is this clearance volume? Yes, we see this is here. Piston is our TDC. So keep in mind this word. Always piston should be at TDC. And when piston is at TDC, then at that condition, the piston top means this length, and cylinder head means this length. Between the space top and cylinder head is known as clearance volume. So when piston reaches at TDC, then there is always some gap between piston top and cylinder head is known as clearance volume. So it's represent here each small space between piston top and cylinder head. But condition is what? Piston should be at TDC, top at center. And this volume is known as clearance volume. Why we need this clearance volume? There are major four reasons that we are occupying compressor with. clearance volume. Number one, prevent striking of piston at cylinder head. If we didn't keep that clearance volume, then what happened? When piston moved from BDC to PDC, then it might strike, chances that piston will strike through cylinder head and cylinder head might get damaged. So by keeping clearance volume, we avoid the striking of piston to cylinder head. Another one chances is thermal to by allow thermal expansion. We all are aware that during compressor air will get heated, and due to that rising temperature, there is always chances to get thermal expansion of metallic body. There are always chances to get little bit thermal expansion in piston. So the dimension of piston will get rise. So there is chances that when piston moves from BDC to PDC, and it will flow at cylinder head, it will not move further. So clearance volume will allow that thermal expansion also. Maintains manufacturing processes. If we have any manufacturing production, then there are also chances to flow piston and cylinder head. So it will also allow to occupy that main manufacturing processes. But most important is according to valves. If we didn't keep clearance volume, then it is very difficult to operate the valve mechanism because valve is getting operated here only. These are the four main reasons get the clearance volume in reciprocating air compressor. Here, we let's now discuss. Let's we go further with our working principle of single edge reciprocating compressor with clearance volume. Now we are considering with clearance volume. What happened in clearance by keeping this clearance volume? This one is T diagram of reciprocating air compressor with clearance volume. What happened? We discuss. Initially, the process which suction process will follow regularly during first cycle. Will get compressed from 1 to 2. It will deliver from 2 to 3. But what happened? After delivery, when delivery process is completed, after that process, there are little bit night, but not little bit, but there are always chances to get trapped air in that clearance volume. 100% supplied air, suction air will not deliver during delivery stroke, but it will get trapped in that clearance volume between piston and cylinder head at delivery pressure. Let's be assume that compressor is done with 6 bar pressure, then little bit amount of air with 6 bar pressure will be trapped within a that clearance volume. And what happened? During that second cycle of compressor, piston will move from PDC to PDC. And during that motion of piston from PDC to PDC, piston will move, cylinder volume will increase. Then due to increasing that cylinder volume, pressure will get decreased. But now the pressure is not atmosphere, so it will not go beyond the atmosphere, but it will decrease from delivery pressure to atmospheric pressure. So pressure will get decreased, but suction will not start. Here, so this process is known as expansion process. 3 to 4 is showing the expansion process. That's nice. Then what happened? After reaching piston up to certain level, when piston go from PDC to PDC, then and then only pressure will get decreased and air will supply from atmosphere, and our suction process will get started. So this one is PV diagram along with clearance volume. Let's we analyze this PV diagram. What happened? Work induction. We all are aware with thermal terminology that any thermal system, the closed area in PV diagram is known as work transfer, and the closed area in TS diagram, temperature versus entropy diagram, is known as heat transfer. So we are dealing with work transfer. Without clearance volume, the area will be like this: 1, 2, 3, E, 4, and 1. So it will consume such amount of work. When we use clearance volume, then area will be 1, 2, 3, 4, and 1. Means area get decreased due to use of clearance volume. The area will reduce, which is positive, advisable, and we need, and based on that, we can reduce work consumption. What happened with air suction and delivery, and whatever. Without clearance volume, air will supply from year to year, year to one. But using clearance volume, the air will supply only from port to one. Means supply of air will get reduced, which is not advisable for us. So it have a negative impact on our customers. What happened with delivery? Without clearance volume, the delivery will be from P to E. But using clearance volume, the delivery will be only 2 to 3. There is little bit reduction in delivery process also, which is also not advisable for our thermal performance of air compressor. So due to clearance volume, work consumption will definitely decrease, but air suction and air delivery also get reduced, which is not advisable for better performance. So engineers are always design compressor based on optimization of these parameters. Yeah, good. Next we discuss multi-staging. Majority industrial application of air compressor are always along with multi-staging. There are very little application of air compressor with single cylinder. Always industrial people are using air compressor, reciprocating air compressor along with multi-staging. What is multi-staging? Multi-staging means use of more than one cylinder to compress the air. I give one example. I need 16 bar vessel, if I need 16 bar vessel, I will design compressor which consume air from atmosphere 1 bar and it will supply air at 16 bar, then it's known as single stage. Because only and only in one stage air will get pressurized from 1 bar to 16 bar. But what happened? In multi-stage, let me take example of two stages, which there are two cylinders. In first cylinder, air will come from atmosphere at 1 bar. It will increase pressure from 1 bar to 8 bar. So at delivery of first cylinder, only pressure will be at 8 bar only. Then what happens? That 8 bar pressure will go inside the second one cylinder. It will increase pressure from 8 bar to 16 bar. So what happens? First air get pressure from 1 bar to 8 bar, and in another cylinder air get pressure from 8 bar to 16 bar. So here the rising pressure from 1 bar to 8 bar is getting increased by 2 stages. So this compressor is known as 2-stage compressor. If the pressure get raised by 3 stages, means let's example 1 bar to 5 bar to 10 bar, and 10 bar to 16 bar. If pressure rise in 3 steps, then it is known as 3-stage compressor. Next terminology is multi-staging. Now the question is, why we need multi-staging? Why engineers are not designing only single cylinder? If we suppose if I need 20 bar vessel, then I simply want to construct one reciprocating compressor which consume air from 1 bar vessel and produce 20 bar vessel. But they are not designing in such that manner, but they are designing system with multi-staging. Why that? They are designing that. Let's I will explain with PV diagram. So this one is PV diagram. We all are aware with this diagram because we already just discussed with this diagram. 1, 2, 3, 4, and 1 6. Here is suction, compression, delivery, and expansion. Next, we take one technical example. That assume this compressor deliver this air at 6 bar pressure. So at the delivery of this compressor, we will get pressure into 6 bar. Now, the industrial demand is to supply for next for giving pressure speed 6 bar. The suction process will 4 to 1, compression is 1 to 2, delivery 2 to 3, and expansion will 3 to 4. Now the demand will get rise from 6 bar to 8 bar, which we need to produce pressure at 8 bar pressure. And we need to produce air at 8 bar pressure. So what happens? for producing 8 bar pressure, we have to grow this compressor apart from point number 2. Then what happens? Suction will happen from 4 to 1. Suction process will definitely happen. Then what happens? 1 to 2, we will get only 6 bar pressure. We need 8 bar. So we have to go beyond this point number 2. So we have to increase point number 2 from this point to little bit upper position. And it will definitely be at this 2 days point. Then what happens? By compressing from 2 days, we will get definitely 3 days as a 8 bar pressure, which is a requirement. We can get that fulfillment. But whatever. Let's we take analysis of this diagram. Whatever. Previously, the suction process was from 4 to 1. Now the suction process is 4 days to 1. So by increasing pressure, our suction gas reduced. One thing. Another thing. Let's see for compression. The compression process will followed by 1 to 2 days. Means compression get increased, maintain higher pressure. Then what happened? Delivery. Previously the delivery was from 2 to 3. Now the delivery is 2 days to 3 days. Means the air delivery also get reduced. So we will get little amount of air as compared with previous one. We will definitely get higher pressure, but we will get amount of air at lower level. The expansion process will followed by 3 days to. Yes, again the industrial demand get raised. They need higher pressure apart from 8 bar. Yes, they are calling for 10 bar pressure. They called engineer that I need 10 bar pressure for my system. Give me 10, air at 10 bar pressure. An engineer would be then an engineer is like you and me. What will we do? We again increase our compression. So 1 to 2 to 2 days we are getting 8 bar. We need far more than 8 bar. So we will go away from this little bit higher than this 2 days point. Let's we go 2 days to double days point. Then whatever is this process. Compression is followed by 2 double days. It will followed by 2 double days to 3 double days. Expansion will followed by 3 double days to 4 double days. Suction will followed by 4 double days to 1. And let's take analysis. By getting P2 double dash means 10 bar pressure, the suction will followed by 4 double dash to 1 means suction again get reduced. Compression get 1 to 2 double dash which compression get increased because we are going to increase the pressure of our system. Delivery process will followed by 2 double dash to 0 means again our delivery will get reduced by increasing pressure. And expansion is followed by 3 double dash to 4 double dash. Again, industrial demand get raised. We need more amount of pressure. Let's say I need 12 bar pressure, all from another process industry. So now the challenge for engineer like you and me have produce air at higher pressure than 10 bar. Means at 12 bar. Assume that we have to produce air at 10 bar pressure. Then what will happen? What will we do? We again expand our compression from 1 to 2 days to little bit higher level. Let's we expand our compression from 1 to 2 days to higher level. Then what happens? Compression will follow by 1 to 2 triple days. Yeah. Then what happens? Let's take analysis. By getting P2 triple dash pressure means 12 bar pressure. What happens? There isn't any suction. There isn't any delivery, but air will just simply compress from 1 to 2 triple dash. It will trap within a clearance volume. It will expand from 2 double dash to 1. Again, it will compress from 1 to 2 triple dash. It will again expand, compress, compress. So trap air within a clearance volume get expand, compress, get expand, compress. But there isn't any delivery, but there isn't any suction of air. So it's uh, very crucial to us that we cannot go beyond the limit of certain pressure. So in this for example, we can only produce 8 bar plus 8 bar pressure using single stage reciprocating, 10 bar pressure using single stage reciprocating pressure. We cannot go beyond the 10 bar pressure. Then what we can do if we need more than 10 bar pressure? So we definitely need to go beyond this single stage reciprocating mechanism. That's known as multi-staging. But apart from this limitation, there are few advantages of multi-staging also. Let's discuss the advantages. Uh, First one is intercooler. What is intercooler? Basically, what about it? Let's take two stages over here as an example. What about in two stage? Firstly, here come from the one bar pressure, it will produce 8 bar pressure, then it will supply to cylinder number 2 at 8 bar, it will produce 16. But using compressor in first cylinder, 1 to 8 bar, when it get delivered at 8 bar pressure, then there is definitely rise in temperature of air also. So there is always higher temperature than atmosphere. And due to rising temperature, the volume of air get increased, which is not advisable to operate with large volume of air. So there is one heat exchanger known as intercooler is in between the lower and higher pressure cylinder, which intercooler works with water cooling or air cooling, in which air higher pressurized air with higher temperature will come from one side, water will come from another side. On the surface of heat exchanger tube, it get exchanged, water will get heated and go away, and air get cooled and go from lower cylinder to upper cylinder. So the temperature of the air get reduced from first stage. At lower temperature, this air will goes to second cylinder. So this process, just we are trying by using intercooler, we are trying to get a process near about isothermal, right? And due to that, power consumption of compressor get reduced. Another is enhanced volumetric efficiency. The volumetric efficiency also get enhanced. Better lubrication due to lower working temperature, because we are using intercooler, so the air wall get cooled, and due to that lower temperature, lubricant will functionize with better condition. Then third one is lighter construction of low pressure cylinder. There is one limitation only of multi-staging, and that one is expensive in initial cost. Let's just simple. This one is my last slide. I will not take my time. Let's we discuss two stages reciprocating compressor. Whatever in two stage, as I already explained previously in virtual media. Now it's on slide. This one is cylinder one, low pressure cylinder. This one is cylinder number two, high pressure cylinder. Air come, atmosphere come in cylinder one at pressure P1, temperature T1. It will get compressed, increased pressure from P1 to P2, increased temperature from T1 to T2. And it will go to intercooler, where it get cooled, temperature get little bit lower, and then it supply to higher pressure cylinder, where again it get compressed and delivered to our receiver. This one is PV diagram. This red color shows compression process in cylinder 1. This one shows compression process in cylinder number 2. Let's take one analysis here. If we didn't use any intercooler, then what happened? 6 to 1, there will be compression. 1 to there will be, 6 to 1, there will be suction. 1 to 2, there will be compression in one cylinder number 1. 2 to 3 days, there will be compressor in cylinder number 2, and 3 days to 4 the delivery. But using intercooler, whatever, the suction will be at 6 to 1, and compressor in cylinder 1 will be 1 to 2. Then we are using intercooler, And due to use of intercooler, we are reducing temperature of air. And due to reduction in temperature, the volume get reduced by 2 days. So now air will not enter in higher cylinder from 2, but it will enter from 2 days. This compressor is followed by 2 days to 3. So this one amount, 2 days, 3 days. This one we can save in our work condition. This is 2 stages. One another thing I would like to uh, put in your mind that if you have observed in low pressure cylinder and high pressure cylinder, there is anything different in dimensions. You getting observed the dimension. Cylinder 1 contains large diameter, cylinder 2 contains low diameter, small diameter. It's my mistake, printing mistake, or anything else. Yeah, it's something special. Or something special. In cylinder 1, air, air, cylinder 1 works with lower pressure air. Means the pressure of air is lower. So the amount of the volume of air is larger. So we need large size cylinder. So always low pressure cylinder contain with large size volume. Whereas in high pressure cylinder, already compressed air from one cylinder number 1 is coming here. So always compressed air is here. So always due to compressed air, the volume of air is lower as compared to previous one. So we need to deal with lower volume. So always in higher pressure cylinder volume is little bit smaller than lower pressure cylinder. Thank you. If you have any query, then you can ask. Uh, Otherwise, apart from this presentation, you can contact me on this media also. Is there any query from audience? Please ask.
Students can ask the questions if you have any query.
Student can unmute your mic and ask the question regarding air compressor.
There are two options. If I am not getting any question from your side, that option number 1, you are getting all thing which I explained, and option number 2, you are not getting anything from my presentation. So, which one is correct one option? Please ask some question. Raise your curiosity.
Neil, Ajay, you can ask the questions. Krishil,
यस मैम
हाँ कोई क्वेश्चन पूछो, कुछ पता नहीं चला वो पूछ सकते हो.
Okay. Now I think there isn't any question from audience. Okay. Thank you, Padul University. Special thanks to Bindi Madam, Padhya sir, Rajasri Madam, to provide me such a great opportunity to address such a large community uh, through this digital platform. I am heartily very thankful for Padul University to provide me such a great opportunity. Actually, this is not first opportunity from Padul University for me, because previously I was working with Padul University. Padul is my base, because I have started my career from Padul University. I learned a lot from Padul University. I got developed in larger manner from Padul University, and due to that development, I am at this level. Already, I have planned much more things regarding my career from Padul University. I also have planned that I will spend all my life with biology, and I already made my road on that sense also. But due to my personal um, issues, I left the biology. But really, I am missing you. Thank you.
Thank you, sir, for providing me such a knowledge regarding the air compressor. The session was very informative for the students as well as the faculty. Thank you very much, sir.
Thank you, madam.
Mehul, sir.